Hello and welcome to the MAML Manual. I'm Sebastien.
And I'm Iris.
And today we'll be doing a short video on the 3 problems in this year's Meet Number 1, Topic Number 2, Inequalities and Absolute Value. Without further ado, let's jump right into it. Alright, here was the first problem in the 2023 Meet Number 1, Topic Number 2, Inequalities and Absolute Value. The solutions for x in the equation, the absolute value of the quantity 7x plus 8 is equal to 69 are a and b. Find the largest possible value of a minus b. Okay, well in this case there are only going to be 2 values of x because there's going to be one that produces a positive 69 and there's going to be one that produces a negative 69, and then when you take the absolute value of negative 69 you will get the result of 69. So let's write that in 2 equations. We can say that 7x plus 8 is equal to 69, or we can say that 7x plus 8 is equal to negative 69. Now all we have to do is subtract the 8 to the other side. So in this case it would be 7x is equal to 61, and in this case it would be 7x is equal to negative 77. Now divide both sides by 7, we get that x is equal to 61 over 7, or x is equal to negative 77 over 7. Now we could simplify negative 77 over 7 to negative 11, but I'm going to leave it as is because we're going to be subtracting the 2 values, and to do that we'll need a common denominator, and we already have a common denominator of 7, so there's no need to simplify that. So now the question's asking, find the largest possible value of a minus b. So basically you can subtract these values in 2 different ways, one that will result in a negative answer and one that will result in a positive answer. Because it's telling us that they want the largest possible value, we want to find the difference that results in a positive value. So in this case we would do 61 over 7 minus negative 77 over 7, which is essentially 61 over 7 plus 77 over 7. So that's what we do. We get 61 over 7 plus 77 over 7. And all we have to do is add the numerators. So 61 plus 77 is equal to 138 over 7. So that is a valid answer, 138 over 7. You can also express it as a mixed number. So you could say that 138 over 7 is equal to 19 and 5/7. So either way, both answers work and both answers are valid. So this was the answer to the first problem in Meet Number 1, Topic Number 2, and now we can move on to the second question. Here's the second question from 2023, Meet Number 1, Topic Number 2, Inequalities and Absolute Value. This is quite a lengthy word problem, but I actually don't think it's too hard considering that it's a 4-pointer. So let's go ahead and tackle it now. 3 siblings of different ages between 10 and 20 are Ashley, Ben, and Carl. So with the names, they're being nice to us, Ashley, Ben, and Carl, we can use A, B, and C in our answer. Also something to note, it doesn't come into play in this question, but I've always been tripped up with the between wording because it can be interpreted in 2 ways. Between can be seen as exclusive, meaning that it does not include the first and the last numbers mentioned, or it could be seen as inclusive, meaning that it does factor in the first and the last numbers. For example, if I told you pick a number between 1 and 10, you would probably think that 1 and 10 are valid answers, or valid numbers that you could pick. If I asked you to find out how many numbers are in between 1 and 10, you would probably tell me that there are 8 numbers from 2 to 9. So that's why I've never really liked the word between. Again, it doesn't affect the answer to this problem, but if it did, I think that they would have needed to be more specific here. They would have needed to say inclusive or exclusive. So just keep that in mind in these problems. So let's continue. Ashley is older than 11, Ben is younger than 19, and Carl is less than 13. The sum of Ashley's age and Ben's ages is 33. The sum of Ben's and Carl's ages is 29. What is the largest sum of all of their ages? So based on the information that they give us, there are different possibilities as to what their total sum could be. So the question is asking us what is the largest sum of all of their ages, so that's something that we have to keep in mind. So let's write out all of the information we have. We know that all the ages are between 10 and 20, so that's just something we know. For the purposes of this problem, I'll assume that's including 10 and 20, but again, as I said, it doesn't impact the final answer. So for Ashley, we know that she's older than 11, so between 11 and 20. We know that Ben is younger than 19, so Ben could span from 10 all the way to less than 19. And we know that Carl is less than 13, so we can say that Carl is between ages 10 and 12, really, because he can't be 13. So that's the information that we have. And then for the sums, we know that A plus B is 33. And we know that B plus C is 29. Now, I'm going to start with C because it's the smallest number of possibilities. A and B both have many possibilities for their ages, but C only has a few. So let's start with C. So we know that C can only be 10, 11, or 12. So let's take a look at this equation over here. If C is 10, then B must be 19. However, we know that B cannot be 19 because Ben is younger than 19, so therefore that's not a valid possibility. What if C were 11? If C were 11, B is 18, and that is valid. And what if C were 12? If C were 12, then B would be 17, and that would also be valid. So these two scenarios are valid, so now we can use these two values of B to test over here. Notice that I didn't continue because Carl cannot be 13 years old. 12 is the oldest age that he can be. So now we know that C can only be 11 or 12, and B can only be 18 or 17, so we can use this information to test over here. So if B is 18, then A is 15, and that is valid because that's between our range of 11 and 20. And if B is 17, then A is 16, and again, that is also valid because it falls within our range. So both of those are valid. So we've gotten two different scenarios where their ages meet all of the conditions. It could be that Ashley is 15, Ben is 18, and Carl is 11. Or it could be that Ashley is 16, Ben is 17, and Carl is 12. So now we have to find the sum of these two different scenarios and find the greater one, because it's telling us what is the largest sum of all their ages. So if we add them up quickly, we know that 15 plus 18 is 33, and we know that 33 plus 11 is 44, so this sum is 44. Down here, we know that 16 plus 17 is also 33, but then we add 12, and 33 plus 12 is 45. So, based on the information that they give us, the largest sum for Ashley, Ben, and Carl is 45 years old. So our answer is 45. All right, we can move to the final problem of this year's Meet 1 topic number 2. All right, here's the final problem of 2023 Meet number 1 topic number 2, Inequalities and Absolute Value. So here's your classic 5-pointer with rational functions where you're going to have to find a lot of critical points. So it's saying find all values of x such that 4 over 3x plus 1 is less than or equal to 5 over 2x minus 7. What makes these problems difficult is all the potentials for intervals. We're going to end up having to test, I think it's 4 values. And then we also have to keep in mind that there are certain values of x that can't be true because we would get a divide by 0 scenario. So I'll go through the entire process of solving this problem and you'll see what I mean, how it kind of gets messy as we go on. As always, with these sorts of problems, critical points are the most important things to find. So our first critical points in rational function problems are going to be where the denominator equals 0. So where 3x plus 1 equals 0, 3x is equal to -1, and x equals -1/3. So that is one critical point. Another critical point would be where 2x minus 7 equals 0, therefore 2x equals 7, and x equals 7/2. So 2 critical points, I'll write them up here. We have them as -1/3 and 7/2. Now it's also important to note that x cannot be either of those values, so I'm gonna just kind of box them out. X cannot be those values because if x were one of those values, then one of the denominators would be divided by 0, and that can't happen. Okay, so those are our 2 critical points, and there's gonna be one more when these 2 functions are equal to one another. So let's do that now, where 4 over 3x plus 1 is equal to 5 over 2x minus 7. And to solve this one, we can cross multiply. So 4 times 2x minus 7 is equal to 5 times 3x plus 1. We can do some distribution. 4 times 2x is 8x minus 28 is equal to 15x plus 5. We can subtract the 5 over to this side to get -33. We can subtract the 8x over to this side to get 7x. So we get the equation -33 equals 7x, and therefore x is equal to -33 over 7. So that's our final critical point, and it's the one where these 2 functions are equal to one another. So that is -33 over 7. And now that one, that is a valid value of x, because if you plug it in, the functions are equal to one another and you won't run into a divide by 0 scenario. So it's only these 2 critical points that x cannot be. Now with our critical points, we can set up, I like to call it a number line, just a basic number line of critical points. So that's what we can do here. Let's set that up. So we have our first critical point would be -33 over 7. Then we have our next critical point of -1 over 3, and our final critical point of 7 over 2. And now we need to test values in between these critical points in order to solve this problem. So for -33 over 7, that's going to be just greater than -5. I'm going to pick a value that's pretty far away, so I'll just say -10. We can test -10. In between -33 over 7 and -1/3, I'll just test -1. In between -1/3 and 7/2, I just see 0. I always think that 0 is a pretty easy number to test. And then greater than 7/2, we can just choose 4. Okay, so now all we need to do is test these values, meaning that we plug those values of x into our original expression to see whether or not it is true. So let's get started. If we plug in -10, 3 times -10 is -30, plus 1 is -29, so we get -4 over 29. And then on the right side, we get that 2 times -10 is -20, minus 7 is -27, so we get -5 over 27. Now the statement says that -4 over 29 is less than or equal to -5 over 27. Well, if these were positive values, let's treat them as positive values for a second. 4 over 29 and 5 over 27. Because the numerator of this one is greater than the numerator of that one, and the denominator of this one is less than the denominator of that one, we know that 5 over 27 is greater than 4 over 29. However, when we make them negative, it's the opposite case, where -5 over 27 would actually be less than -4 over 29, because -5 over 27 is further away from 0 than -4 over 29. It doesn't matter how you want to logic that out. The point is that this is a false statement, and therefore I'll just make a big X, so we know that this is false. Okay, so now we can test -1. If we plug it in, 3 times -1 is -3, plus 1 is -2, and then 4 divided by -2 is -2. So we're comparing a -2 here. And then on the other side, 2 times -1 is -2, minus the 7 is -9, 5 over -9 is just -5 over 9. And now it's asking us to confirm the validity of this statement. -2 is less than or equal to -5 over 9, and that is true. -2 is further to the left than -5 over 9. So that's a true statement, which means this interval is valid. So now we can test 0. If we plug in 0, we just get 4 over 1, which is 4. If we plug in 0 here, we get negative 5 over 7. And of course, it's not true that a negative value is greater than a positive value, so we know that that is a false statement, and therefore 0 does not work, and nothing in that interval works. So the last thing we need to test is the positive 4 value. If we plug in 4, we get that 3 times 4 is 12. Add 1, we get 13. 4 over 13 is the first value. And our second value, if we plug in 4, well, 2 times 4 is 8. 8 minus 7 is 1. And we just get 5 divided by 1, which is a nice 5. And of course, we know that 5 is greater than 4 over 13, meaning that that is valid. So we found that 2 of our intervals are invalid, 2 of our intervals are valid. This is kind of why it's a 5-pointer, and this is why I was telling you it gets to be a mess. This isn't very neat work. I'm trying to do it as neat as possible for you, but again, it's kind of all over the place here, even in an attempt to be neat. So that's kind of how these problems devolve into chaos, if you will. And the numbers aren't great either, but it is what it is. That's this type of problem. Okay, so we have all of the information we need. We just need to be very careful which numbers we include and which numbers we exclude from our final answer. So we're saying that this interval is valid here, from here to here. So that would be from negative 33 over 7 to negative 1/3. However, remember, negative 1/3 cannot be a valid answer because that would make this denominator 0, and we can't divide by 0. So this interval would be negative 33 over 7 is less than or equal to x is less than negative 1/3. Do not put a less than or equal to negative 1/3 here. So that's our first interval. Our second interval would be over here regarding 7/2. So x could be greater than 7/2, but x could not be equal to 7 over 2, because remember, I boxed the ones that x can't be equal to. If x were to be 7 over 2, it would make this denominator 0, and if we divide by 0, we get an indeterminate form. It's not valid. That's one of the vertical asymptotes of the rational function. So that's not a valid value of x. So we have to say that x is greater than 7 over 2, but not equal to 7 over 2. And we need an or in between these statements to indicate that one or the other is true. Okay? So our final answer to this problem would be negative 33 over 7 is less than or equal to x is less than negative 1/3, or x is greater than 7 over 2. This is a complicated problem because it involves finding those critical points, which involves cross multiplication and setting those functions equal to each other. It then involves testing a bunch of numbers, and you have to make sure that you're getting those correct. And then it involves writing the answer in this format, and you can't include the critical points that would make you divide by 0. So there's a lot to that problem, there's a lot involved, but hopefully you followed my work, and who knows, hopefully you got the 5 points in the first meet. All right, that was the final problem for the 2023 meet number 1, topic number 2, inequalities and absolute value. This was our video on the 3 problems in this year's meet number 1, topic number 2, inequalities and absolute value.
Thank you for watching.
I'm Sebastian.
And I'm Iris.
And we're the MAML Manual.